It actually hurts to like type. I hope y'all have heaters on, honestly.
Nah, man. My mom always said we can't touch the thermostat.
Bruh, you gotta Okay, I'm gonna send Belinda the link, okay? Oh, that's not the link I was looking for. Give me 1 second. Okay, I sent her the link. Hopefully she can take a look at it, okay? The ones you buy from LA, right?
Yeah.
Jesus Christ. All right. So just to get back on track, so we have our slope. Now, just a reminder, or just to let you know, this number right here, this is also a linear equation, okay? Y equals mx plus b. We haven't talked about what the b represents. The b is exactly the same thing as your unit rate or your slope. It's the same idea, okay? It's the same number. It's in front of the x. Does anybody know what the b represents? Maybe somebody who's worked on that specific IXL. You're adding, yeah. Does anybody know what the letter represents? And it's totally fine if you don't know what it means or represents. The B represents your starting value. So if you're like, what does that mean? It's your starting value on the y-axis. It will make way more sense tomorrow. It will make way more sense tomorrow. Our IXL skill tomorrow, we're going to be graphing lines, and it'll make way more sense. Okay. So let me type the link to the thingy majingy once more. Okay. I think that's everybody here. Now you good, Belinda. So I think that we have everybody here, at least people who are going to show up. So I just wanted to make a couple of announcements so everybody knows what the expectations are going to be starting today and moving forward, okay? So technically speaking, class starts at 10. And many of the times I have to wait till like 10:01 or 10:02 to actually get started because there's only about 3 or 4 of you who are actually here at 10 o'clock. Starting today, or starting tomorrow, if you show up after 10 o'clock, I am going to deduct half a point from your participation. A reminder that you get 10 participation points every week. You can you get 10 participation points every week, and 33% of your grade is participation. So you can lose a lot of points by coming in late to class. So you'll be losing, right? You're going to lose half a point for coming in late. So I think more than half of you today would have lost a point if I had started counting today. But starting tomorrow, that's when I'll be taking points off for being late. Um, you can get those points back by participating when I ask people to, hey, does anybody want to give an answer here? And if you unmute yourself and give an answer, you can get those points back. Okay. Similarly, a lot of the times I ask on you to, read something or to give me your opinion on something or to give me an answer on something. And you don't unmute yourself. You kind of just stay there quiet, not saying anything. So I'm gonna give you about 5 or 6 seconds to respond. And if you don't respond, again, I'm gonna take away participation points. Um, it's expected that like you're attentive and you're there in front of the computer. So if I say, for example, Andres, can you please read me this problem? And if 5, 6 seconds go by and I just don't hear anything from you, like I'm gonna just move on to the next person and take away points for participating, okay? Um, Last announcement. So, as you all know, you can find Jamboard on Canvas. I don't think it's this class. I think it's my other class that always is asking me for the link. And I'm like, bruh, the link is on Canvas. So I'm not gonna be posting the link anymore in the chat. It's going to be expected that you go to Canvas, click on the link so that you know what we're doing. And I'm gonna show you right now how to do that, okay? So you're gonna click on dashboard or, for your class, click on our math class and I'll do student view so you can see how it looks on your end. You're gonna click on modules. And then we are in week 5. How do we know that? Because today's the 9th, right? Yes, today's the 9th. Class notes, exit ticket, and our homework are all here. You're gonna click on class notes, and then depending on what cohort you're in, we're all in cohort A, you click on this, and it takes you to the notes. So Jenny, I know you came in late. Moving forward today, I'm not gonna be posting the link for the Jamboard. I'm going to be expecting that people click on it on their own, just because it takes a little bit. It takes away time, okay? Especially when you come in like 10 or 15 minutes late, and people are like, "Where's the link?" Grr. Um, oh yeah, Jenny, and starting tomorrow. Wait, let me stop screen sharing. Okay, starting tomorrow, I'm going to be taking away points for people that are coming in late. So if you're going to be coming in late because I don't know, for whatever reason, reach out to me. Let me know either via text or an email, letting me know that you're going to be late, okay? Are there any questions about the expectations? Okie dokies. So this is not to spite y'all. It's just, you know, it was getting annoying on my end. So I'm just letting you know what I'm going to be doing from now on. So let's go ahead and begin. Here we have 2 different graphs. 2 large water tanks are being filled with water. Tank A is not filled at a constant rate. And the relationship between its volume of water and time is graphed on each set of axes. So both of these are the same graph, except if you look at the time right here, this only goes from 0 seconds to about 2 minutes. Whereas the second graph goes from 0 minutes to almost 100 minutes. So imagine the graph, right? You zoom out and you get to see what's actually happening in the long run. And that's what we're looking at, okay? So tank A is not being filled at a constant rate. So this means 1 minute they're filling 3 liters of water. Another minute they could be filling in 10 liters of water. It's not constant, it's different every second. Whereas tank B is filled with a constant rate of half a liter per minute. So 2 tanks Okay, tank A, tank B. This one is being filled with random levels of water every second. This one is being filled a specific amount every second. The relationship between, the relationship between its volume of water and time can be described by the equation V equals 1/2 T, okay? So V equals 1/2 T, where T is how many minutes, and V represents the total volume of water. We don't have an equation for the red one. We don't know. So, I know, right? So in the chat box, should have had this typed up beforehand. After 30 seconds, which tank has the most water? So let's go back to the graph. After 30 seconds, who has more water? The graph or the equation? So for extra credit right here, using the first graph, can I please have somebody tell me how many liters of water are there after 30 seconds, also known as half a minute?
About three.
3 liters?
Yeah.
Okay, can you explain to the class how you got that? Using the graph, this graph right here?
So I went, since we know, oh rats, I got it wrong actually. I was
Oh,
thinking like in seconds,
uh-huh.
but it turns out it's going by like tens, on the bottom for minutes.
Okay, 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 yeah, yeah, yeah. So this right here, this is 1 minute, right?
Yeah,
How many seconds is that?
will be about 5 liters actually. 60 seconds.
Okay, okay, but what I'm asking is how many seconds are there in a minute?
60.
60, right? And I hope everybody else agrees with that. There's 60 seconds in 1 minute. So where would 30 seconds be on this x-axis?
Between the 4 and 6.
Yeah, between the 0.4 and the 0.6, right? Because it should be 0.5. Okay, so here's 30 seconds. Do you want to change your answer? Maybe tell me how many liters are there in 30 seconds?
5.
5 liters or 0.5 liters?
0.5.
Ah, okay, okay, okay. So Andres, thank you so much. Everybody, just a reminder that you want to be specific when I'm asking for certain quantities, right? Andres knew there was supposed to be a 5, but he was telling me 5 instead of 0.5. Because 5 would be, first of all, this is 1. So 5 would be all the way up there. So it looks like there's about, actually, is it more than 0.5 or is it 0.5 exactly?
More, but I think it's more reasonable to say 0.5 because it's easier to remember it like that.
Okay, it's a little bit, yeah, yeah. So I'm gonna go ahead and agree. It's a little bit more. It's more than 0.5, but it's less than 0.6 because obviously the red line is below 0.6, right? It's below 0.6. Wonderful. And according to the equation, V equals 1/2 T. Let's see. 30 seconds. How do I write that as a fraction? Like a minute.
3/1. I mean 30/1.
30 over, well, how many seconds are there in a minute?
60. So 30/60.
Yeah, thank you, Kathy. 30/60, right? And let's see, maybe somebody different from Andres. Who can tell me what 30/60 is as a fraction? And this is for extra credit. Enrica, say it. Unmute yourself and say it.
1/2.
1/2, right? 30/60 is 1/2. So 30 seconds is the same thing as 1/2. So we want to know how many liters of water we have after 30 seconds using the equation, okay? So 1/2 times 1/2. What is 1/2 times 1/2? Anybody? If we're adding them, it's 1. But what if we're multiplying? How do we multiply fractions?
Keep it, flip it.
That's if you're dividing.
Oh.
That's if you're dividing.
Wait,
Anybody remember?
Don't you just time it across?
Yeah.
1/4.
Yeah. You just multiply it across. Wonderful. So for the second tank, there's about 1/4 of a liter of water after 30 seconds. But for the red tank, there's about more than 0.5 and less than 0.6. So who has more water at 30 seconds? The red one or the blue one? Type into the chat box, what do you think? Is it the red one or the blue one? And I'm not going to call on people to explain their answer, okay? This is simply for participation. So which one do you think is going to have more water after 30 seconds? Or sorry, at 30 seconds? Okay, I see most people are voting blue. We have one person who says red. Okay. Somebody who voted blue, do you want to go ahead and state why you said blue? Notice how I'm not picking on somebody. I'm letting people unmute themselves and explain. Nobody? Okay. Somebody who picked red, do you want to go ahead and unmute yourself and explain why you think it's red? Why do you think red has more water after 30 or at 30 seconds?
At 30 seconds, red would have 0.5, right?
Up a little bit more than 0.5.
And then 1/4 would be 0.25, if I'm not correct, right?
Yeah, 1/4 is 20.25.
And if I'm, correct, I believe 0.5 is double 0.25, right?
Yeah. 2 times 25 is 50, so yeah.
All right. So that's why I said red at 30 seconds.
Do y'all agree with Virgil's explanation? I mean, he converted 1/4 as a fraction to a decimal, and he saw 0.5 is bigger than 0.25. So then the red graph should have more water at 30 seconds. All right. I think the students are flabbergasted. Um, so the red definitely has more water. Red definitely has more water after 1 minute, or sorry, after 30 seconds. So what I'm gonna do now, okay, or actually before I move on, are there any questions? If some of you are still wondering why red has more water, this is your time to speak up. Because red definitely has more water. Okay. So now we're gonna take a look at what time do both tanks have the same amount of water. This graph right here, this is the red equation, or sorry, the red graph. We don't know the equation for the red graph. We want to know at what point do they have the same amount of water. So how do you do this? Well, you need to graph this equation. So using your notes, right, from our vocabulary, what is the slope of this equation? And I know it doesn't have any x's or y's, but technically this would be y equals 1/2 x. So using your notes, what do you think the slope is? Okay. Let's see. Belinda, hopefully you've looked at the notes. What do you think the slope is for this equation here? Okay, thank you for being honest. Bricia, what do you think the slope is according to the equation? Thank you, Bricia. 1/2. Belinda, just a reminder, I know you came in a little bit late, and that's totally fine for today. The number in front of the x, that's the slope. It's the number in front of the x. So I'll just slope, what happened? The slope is 1/2. Now, slope is the ratio of the rise. What's up?
You think you can show them how you got 1/2? I think they might be confused.
Oh, yeah. So, according to our vocabulary, oopsie, the number in front of the x is our slope. So, Belinda, I know you weren't here for this part. The number in front of the x is our slope. Sometimes we give you an equation and we ask you, what's the slope? And you just have to remember it's the number in front of the x. So I'm sure Bricia remembered, hey, we just did this in our vocabulary. It's the number in front of the x. Now, if we had a graph, I could totally show you how to find the slope. But for tank B, right, the blue equation, we don't actually have the graph. We're going to graph it. Did that kind of help?
Yeah. I was thinking like if you can show them the rise and the run on the red graph.
Oh, well, the red graph is not linear.
The one on the right?
Yeah, the red one. It's not filled at a constant rate. So it's not a linear equation. It looks linear,
Oh, okay.
but I'm gonna show them using the blue graph how we can find the slope.
Okay, okay.
So the rise over run is 1/2. And this is a proportional relationship, right? So we start at 0. And if we go up by 10, how much do I have to run, or how much do I have to go to the right so that it's proportional to 1/2? 10 over what number is equal to 1/2? Ooh, Andres. 5 over 10 is proportional to 1/2. What number, if you take half of it, you get 10? Yeah, 20. Right? Half of 20 is 10. And remember, this is to keep things proportional. So if we go up by 10, we're going to go all the way to the right by 20. What if you go up by 20? What number is half of 20? Or sorry, if you take half of this number, you get 20. 20 over what is the same thing as 1/2? 40. So if we go up by 20, you go up by 40. Once you have a couple of points, you can go ahead and graph. I know this looks very messy. So I'll go ahead and erase. Actually, no, I want to leave that there. And I'll just erase this part right here. It's difficult to see, but when you graph both of the points, or sorry, the blue equation, they both cross at this point. Can somebody other than Bricia or Andres tell me what is my x coordinate there and what's my y coordinate there? And this is for extra credit. I should tell you this. This is for extra credit. Yeah. For those of you who private message me, x equals 60 and y equals 30. Yeah. 30 and 60. Wait, no, I just did that wrong. 60 and 30. 60 minutes, 30 liters of water. And you know this is true because at this exact point, the two lines are crossing each other. When two lines cross each other, not only are the x values the same, right? They both have the same x coordinate, but they both have the same y coordinate as well. Same x and same y. So after 60 minutes, they both have 30 liters of water. So what's important here? The important thing is to recognize that a proportional relationship, right? That's one that starts at the origin, is going to grow at a constant rate. And something that is not constant will have like a curve. It's very difficult to see, but it curves. You can kind of see it better right here. You see a little curve right here. Let's move forward. We're going to practice a 3 reads protocol. The 3 reads protocol allows us to read the same problem 3 times, but each time we read it, we think of the problem from a different perspective. The first time you read a problem, you're just going to read it to figure out what is the problem talking about, okay? So, Cristiano, can you go ahead, unmute yourself, and just read the problem here? Just read us the problem.
Where it says the origami.
The origami, yeah.
The origami club is doing a car wash fundraiser to raise money for a trip. They charge the same price for every car. After the 11 cars, they raised a total of $93.50. After 23 cars, they raised a total of $195.50.
Thank you so much, Cristiano. Darelli, can you let us know what is this problem about? What is it about? What is it talking? Can you say it again? I think you muted your mic very quickly. Okay. Be sure to let me know though what's going on, okay? Fatima, you heard what Christian said. He read the problem. What is this problem about? What's happening in the problem?
A car wash fundraiser to raise money for a trip.
A car wash fundraiser, right? Thank you so much. So we know the problem is about a car wash. Car wash fundraiser. Thank you. So, let's see, do we have to read it a second time? Yeah, let's read it a second time. So, Hairista, if possible, can you please go ahead and read out the problem again? Or sorry, the problem statement?
The Origami Club is doing a car wash fundraiser to raise money for a trip. They charge the same price. After 11 cars, they raised a total of $93.50. After 23 cars, they raised a total of $195.50.
Thank you so much. So I forgot to mention this, but the second time you read a problem, now that you know the problem is about a car wash, now you start to look for the important pieces of information. So, Italy, what's one important thing about this problem that we should probably know?
After 11 cars, they raised 93.50 cents dollars.
Thank you so much, Italy. Jade, what else do you think is important about this problem?
After 23 cars, they raised a total of $195.50.
Yeah. After 23 cars, they raised a total of $195.50. Thank you so much. So we got the 2 pieces of information that are important about this, or at least we think are important. So I'm not gonna have y'all read it a third time, but now that you know that the problem statement is about a car wash and we know some prices for a certain amount of cars, what do you think would be some of the questions that they could ask? In the chat box right now, if you were the one writing this problem and this is all the information you gave the person, what would be some questions you would ask the student so they could answer using this information? Imagine you're the teacher and you're writing down problems. What could be a question you could ask? Thank you, Bricia, for getting us started. Everybody else, go ahead. I'm gonna give you about 30 seconds to write down questions. What do you think is a question you could ask? Thank you, Shayla. Thank you, Jade. Thank you, Heidista. So for those of you reading the chat, well, only a couple of people publicly put their questions out. And most of you are private messaging me. You should be putting all of this in the public chat. All of you are correct, right? These are questions that you could totally answer. Go for it, Angel. Thank you for letting me know. Just a reminder though, you do have those two. Never mind, he left. All of you are asking, how much is it to wash one car? What is the unit rate? And you are absolutely correct. That is actually the question that we're going to ask you. What is the unit rate? So, does anybody have the unit rate? Does anybody know how much they're charging per car? Right, we want to know what's the total cost per car. What do you think we have to do? Ooh, Bricia, unmute yourself and say it.
I think we have to divide.
Absolutely. You don't think so. You know so. We gotta divide. So what's it gonna be? Is it gonna be money divided by cars? Or is it the other way around? Cars divided by money. What's up, Andres?
Money is divided by cars.
Money's divided by cars. Yes. So go ahead. If you have a calculator, go ahead and divide right now. And tell me what it is. Be more specific, Andres. Be more specific. What you mean 8.5? 8.5 what? All right. So according to Andres and Bricia, we take, for example, I'll take this one right here. You take, let me move this down here. $93.50 divided by 11 cars. And yeah, it looks like people are getting $8.50 per car. So all you did was divide the Y value by the X value. Right? This is technically your X and this is your Y. So all you did was divide the Y value by the X value. So this is our unit rate or our slope. Does anybody feel confident to try to give me the equation? We did this last week where we had like 10 different problems where you found the unit rate and then you wrote the equation for it. What do you think the equation would look like? I'll give you a heads up. It's gonna be y equals something x. What do I put inside? Or sorry, what do I put in front of the x? Yeah. Thank you, Bricia and Enrica. We put 8.5 because that's our unit rate. That's how much each car costs to wash. If you were struggling writing out the equation, just a reminder, our notes, the equation is y equals k times x. Our unit rate is just a number in front of the x. You can always write an equation. The unit rate will be the number in front of the x. So the unit rate, right? It's the number in front of the x. And last but not least, let's graph this. Last time we graphed, we found out you can set up your own axes. What does this mean? This means on the x-axis, for example, here, if this is going to be 1, this is going to be 2, this is going to be 3, this is going to be 4. We have to keep it consistent. And on the y-axis, same thing. If this is going to be $8.50, the second number better be 850 plus 850, which is $17. And so on, and so on. A mistake a lot of people tend to do, they make this 1, and then they make this 2. Notice how the gap here is just 1, but then up here, it's 3. So, once you have all your pieces together, you can go ahead and just start graphing. One car is $8.50, 2 cars is $17, and you have your equation. Ooh, I see some of you are already turning in exit tickets right now. So how can you calculate or see the constant of proportionality in each of representation? So the constant of proportionality here, the way we see it is, this changes by 1 and this changes by 8.5. So 8.5 divided by 1 is 8.5, which is your unit rate. So this constant of proportionality shows up in the equation, on the graph, and on the table when you divide. So I have an exit ticket for you. And I'm gonna tell you this right now. Look at your notes. Look at your notes. It's an easy 4 points if you are taking down notes. If you didn't take notes, look at the Jamboard. Everybody should be able to get these 4 points, and I know you will. When you have finished the exit ticket in the chat box, please finish. Please write done when you finish the exit ticket. Thank you, Andres. Michael, yes. Read the message I just sent you. Have a good one, man. I don't know what you said. Se te cortó todo lo que dijiste. If you are finished with the exit ticket, do not forget to do your homework. Yeah, don't forget to do your homework. But you can go ahead and log off. Have a good one. Awesome, Jade. Yes, you can go. Once you finish, you can go. And then Stephanie, Saul, Noah, Kevin, Kathy, Carla, and Dareli, if possible. Let me know. Let's see. I'm gonna give you the link to the exit ticket. And just a reminder, you can do this. You can look at the notes for it. Okay. Awesome, Stephanie. Thank you all. Noah, Kathy, Carla, and Dareli. Dareli, first and foremost, I just want to appreciate you for turning on your microphone and communicating with me. I think it's the first time I've actually communicated with you in a really long time. Carla and Kathy. Kathy, I didn't see you participating much today, but Carla, you did speak up. Thank you on that. Noah, you'll get an opportunity tomorrow or in the next couple of days to participate, okay? But everybody else, thank you all. And wear some nice clothing. It's cold. I'll see you later, alligators.